Good morning, 7th grade. Today we will talk about refraction. I think we didn't talk about the periscope. It's very easy, you can read it by your own. Periscope allows us to see things that we can't see directly. For example, in a submarine, if we have someone here in submarine, under the sea, they want to see up, they want to see the shore. Okay, they use this periscope. It is composed of two tubes, a horizontal tube and vertical tube, with mirror on the edges of the vertical tube. So the light from the object will come to the first mirror, it will reflect to the other mirror, then it will reflect to your eye so you can see. Please read. If you don't understand it, ask me and I will explain it to you. Now we will go to refraction. As we said before, when we have a light ray that is, let's go to this one. Actually, I want to use this one. When we have an incidence ray that hits the surface of a transparent object, we said that incidence ray, what will happen to this light ray? Part of this ray will reflect, part of this ray will refract, and part will be absorbed by this surface. Now, about this part, we talked about it earlier. We said that refracted light will be refracted upon a shiny surface, and we said this is according to the law of reflection. Angle of incidence will be equal to the angle of reflection, and we will have the refracted ray. Now, today we are going to talk about this part, which is the refracted ray. As you know, the speed of the incidence ray in the air differs from the speed of the incidence ray in the material, and this difference in the speed will cause a difference in the path that the ray is taking. Okay, so here we will have angle of refraction less than angle of incidence. This is the angle of incidence, the angle between the incidence ray and the normal line. The angle of refraction, the angle between the refracted ray and the normal line. So as you can see, the difference of speed in the air and in the surface will make the ray change its path. The angle will change. We will have a smaller angle here. This change in angle is called refraction. So refraction is the change in the bending of the light when it enters a different media. What causes this bending? It is the difference in speed. So let's go here. As we said, yes, light travels in a straight line, but we have to put here a note: in the same media. Okay? And what is refraction? When we change the media, when we have two media, when we have air and glass, here the light will bend. This bending is called refraction. So refraction, the bending of light when it enters a different medium. What is the cause of this bending? It is the different speed of the light in these media. Okay? Now let's see investigating refraction in this activity. Set up the equipment as shown in figure. We have a glass, we have a single ray box which will produce one ray. Okay, now as we said, what will happen to this light ray? As we said, part of it will refract, part of it will reflect, and part of it will be absorbed by this media. Okay, look at your drawing and at figure 7.20 and this figure that we already looked at. Rays that enter the glass along the normal line do not bend. This one, it will not bend, it will continue its path. Okay, the ray bends toward or away from the normal line. When it enters the glass, it will bend toward. As you can see here, the angle is smaller, so it will bend toward the normal line. The refracted ray will be near the normal line when it enters the glass. When it leaves the glass, it will bend away from the normal line, here, away from the normal line, and this ray will be parallel to that ray. So again, when the incidence ray enters the glass, it will bend toward the normal line. The angle is smaller. And when it leaves the glass, it will bend away from the normal line, so the angle will get bigger. Okay, that's it that you have to know for today. Thank you for listening.